and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Scott Cain.
Good morning, good afternoon, or good evening. Thank you for spending a few minutes with us at KYZEN today for this version of today's Tech to Tech. So today what we will be talking about is why pH is not an acceptable concentration control method. I'd also like to shout out Gary Liu and Jason Chan, who have assisted on this project. My name is Scott Cain, and I'll be walking you through this. So what is an acceptable concentration control? Well, let's talk about what concentration control is first. So when you're utilizing an engineered chemistry, before a chemistry can even come to market, the team will work diligently to make sure what ranges that material will work best in. Where it's going to be too low, it can cause some issues. Can be too high, it can cause issues. And so what we want to do is we'll make sure if we're using those chemistries, they're right inside of that acceptable range. And there's a number of ways to extract that information. So why is concentration monitoring important? Well, if we're too low, the chemistries are made up of a couple different ingredients that have different skills. One is a foaming package, a defoaming package. And if that material if there's not enough of the defoaming agent inside of there, then we're going to see foaming. Additionally, we're going to see corrosion. We may see, and this happens if the concentration is too low or too high. If it's too low, we're going to have corrosion from what's left on the boards. And if it's too high, the chemistry itself could cause some corrosion. And most importantly, if the concentration is too low, we're going to have an inefficient cleanliness. Whatever your cleanliness standard is, we cannot get there if the concentration of the chemistry is not high enough. But on the other end, we don't want to go too high, right? We talked about the corrosion. You're going to be spending more on the chemistry. The chemistry costs money. We want to make sure it's just the right amount is used. And if the concentration is too high, you're using too much chemistry to get the same cleanliness level that you can get with the chemistry that's within the range. And it can have an effect on any of the labels or markings that are on the parts. It just becomes tougher for those to withstand the cleaning process. So that's why we want to make sure we have that concentration monitoring dialed in. There's a couple ways that can be done. One is a refractive index, and this is historically used on hydrophilic materials. So when we talk about hydrophilic, we're talking about materials that mix well together. The opposite of that would be a hydrophobic material, which they're going to separate if there's a lot of mixing going on. The refractive index can be used to measure concentration because it reflects how the light travels through that medium. The different concentrations in a solution has different RI. The higher the concentration, the higher the refractive index. Now, one thing with refractive index is it can be affected by the temperature. And so we want to make sure there's consistency on what temperature you're running your refractive index testing. Another way that we do this is by sonic velocity. And sonic velocity is the best way to dial in that concentration, to know what's going on. So what that is doing is using sound waves to determine how much of each material should be within the concentration at that point. So it's not just testing the overall, it's testing the individual ingredients that are in there. And then we know what those sweet spots are, where the concentration is, what that sonic velocity should be. And so that'll read out on some of the options that we offer. And that's going to have, and the temperature is also going to play a part in that. So when we talk about refractive index between KYZEN and some of the KOH based products, and KOH, just to make sure we're all on the same page, is the potassium hydroxide products that are out there. So you can see on the left, this is one of our materials, and we can see what those bricks numbers are, which is the number that you're going to get from that refractive index. So let's say we get 7.0. As we see on that screen, that's going to be 8.5% concentration. Well, you'll also notice that you'll also get something that could be 8.3 or 8.0 or 8.8, depending on which way that is from that number. So you can see that the increments are very, very small on that. Well, when we go to some of the KOH-based products, the concentration is 1 to 10, and there's an inflection point that we talked about. But some of those KOH products, the concentration range is narrow for these advanced packaging applications. We want to have it within a couple percentage. But you can see that there's subtle differences that can create a big change in what that concentration variation is. And so you're not dialing in as well with potassium hydroxide materials. So when you're using something with the bricks, you're going to know exactly what that is, but you could have plus or minus 5% within a very small range with those potassium hydroxide based products. And again, with the sonic velocity, there's no inflection point within the working temperature range. So if we're within that temperature range, then we know exactly what that concentration is going to be. On the flip side, some of those other ones that may be using pH to determine it, there's an inflection point above 129F or 54C. And therefore, they're not going to be able to determine what that concentration is outside of those. When there's an inflection point, the information becomes too muddled to extract a consistent concentration. So what we're looking at is trying to find out what those ranges are for each of the sonic velocity versus a KYZEN product and a KOH based product. And the KYZEN product is going to have a much wider range to be able to do that. So you're going to be more dialed in on your process. Again, not spending too much or too little on your materials. So is pH the proper method to monitor the concentration on these KOH based product? And this just is the complete disassociation of KOH and water means the hydroxide ion concentration equals the KOH concentration. And this concentration can be used to determine the solution's pH. But the pH doesn't take into all the other consideration all the other things that may be in the material. It does get fluctuated. There could be plasticides in there. There could be other materials that change that pH. And so that's not really going to acknowledge what the true concentration is, where if you're losing something like sonic velocity, all of that is taken into consideration because we know what happens within those different ingredients inside of the product. So no, we don't want to use pH to monitor the concentration on these advanced packaging applications, which have a very small window of what the concentration should be. What are the ways we can maintain that consistent concentration? So we can use the sonic velocity that we talked about, and KYZEN has two products that utilize that. One would be the KYZEN PCS. KYZEN PCS is an all-inclusive machine. What will happen is it will document all what the concentration is. It uses the sonic velocity to determine what the concentration is. And then if it needs to add water or chemistries to stay within that range, it's going to do that automatically. There's no manual testing on it. There's no having to manually add water or chemistry to keep that concentration. We also offer the KYZEN Analyst. The Analyst is more historically used in the batch machines, but it's going to use that same sonic velocity. But what it will do is check that concentration. But if it's going to need to be changed or modified, that's going to be a manual. But it gives you a nice visual reading as you're getting ready to put any of your product inside of the machines. So kind of in summary, pH is not the best practice to monitor the concentration of the KOH based product due to its pH, and it's affected by a lot of things, not just the concentration. Again, we talked about the flux loading, other contaminants that come into the process. That KOH based product is not going to be as precise as you would like. Both refractive index and sonic velocity are acceptable procedures to inline monitor the concentration so you can see what's going on. Cleaning processes without inline concentration monitor may create corrosion, insufficient cleanliness, which is the most important, or foaming issues that can have an effect on the floats, have an effect on your production because it'll show an error which might not actually be there. And traceable concentration history is the key to maintain process consistency. Knowing what has happened in the past, what the process parameters were, allows us to know what's going to happen in the future. And having that documented in a format that works great for an audit or anything like that is going to help that. Whereas maybe a piece of paper is not the best way to do that. So some of the frequently asked questions that we get on this topic, why does the corrosion occur at both too low and too high of a concentration? Kind of touched on this earlier. If it's too low, then the existing contaminations that are there that can create corrosion are not going to be able to be cleaned off enough. And if there's too much of it, it's the material does become powerful as the concentration gets higher and higher, and that can create corrosion. Between the refractive index and sonic velocity, which one is more accurate for concentration monitoring? The sonic velocity is a little bit better because it takes any of the manual variances out of it. You know, if both yourself and myself, we were to do the refractive index, how we're pulling that sample, what the temperature is, how long we're waiting before we're comparing it to the bricks is going to be vary just a little bit. Whereas with sonic velocity, it's consistent because a machine is doing it. It is doing it the exact same way every single time reading that information. If there is white residue, insufficient cleaning, caused by insufficient cleaning, occurring due to low concentration, could it be removed by reclean with a higher concentration? Historically, yes. White residue is a cosmetic error that will happen on the boards. It's not something that historically will cause problems. But if you get that concentration back in line, run it again relatively quickly, then you will be able to remove that white residue. So you're providing a product that meets the integrity that your customers expect from you. If you have any other further questions on this, please don't hesitate to reach out to any member of the KYZEN team. We love talking about this stuff, and we're here to help you. Thank you so much, and have a wonderful day.
Thanks, Scott. Thank you guys for watching this Tech and Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.